Exponent laws. There are a whole bunch of rules when dealing with exponents. You should have been introduced to a bunch of these in middle school. Carson, turn around, face the front. Guntas, stop messing around. Both of you will go sit one on either side of Mr. Minocha if I have to do this. If the two of you can't sit together, he will sit between you. Right up at the front. We'll make a big deal about it. There are ways to make exponents nicer. So there's 6 rules. Is there 6 rules or is there 7 rules? 1, 2, 3, 4, 5, 6. I think I actually do 7. There's a 7th rule that I'm going to introduce you to. There are 7 rules. I will introduce you to all 7. Only 6 of them are required for grade 9, so the 7th will be optional. But it'll just make some things easier to deal with if I show it to you. So, here we go. The first rule that will make our lives a little bit easier when dealing with exponents is called the product rule. What is a product? No, that's the base. Yes, what's a product?
The answer you get?
The answer you get when you do what mathematical operation? Yes. A product is the result when multiplying. So, when I call something the product rule, it only works when you're doing what? Multiplication. So here we go. Product rule. Rule number 1. When I've got something like 2 squared times 2 cubed, there is a nice little rule that we can use to simplify these things. Before you get the nice little rule, I want to show you where the nice little rule comes from. It comes from, what does it actually mean to have a number squared? Times itself. So let's write this out. We're going to expand this. 2 squared is the same as 2 times 2. Times, what's 2 cubed? 2 times 2 times 2. Thank you for not saying 8. You would have been correct, but not what I'm looking for. So now let's look what we have here. If I have 2 squared times 2 cubed, that's the same as 2 times 2 times 2 times 2 times 2. Really, what am I multiplying together? No, that's not what I asked. What am I multiplying together?
8 times 4.
No. What am I multiplying together? 2's. How many of them? 5 of them. So you can write 5 2's multiplied together as 2 to the power of 5. Interesting, though, what's happening here, yeah? I had 2 squared times 2 cubed. I wrote it out like this, and it condensed down to this. Could I have just shortcut this? What can I do with 2 and 3 to get 5? Have neat.
Add them.
I could add them. That's a fascinating little thing. Let's do another one. 7 to the 1 times 7 to the 1. Well, 7 to the 1 is just 7. Times 7 to the 1 is just 7. 7 times 7 is, don't say 49. 7 times 7 is, as a single power, 7 to the power of 2. Oh, look! How can I use 2 1s and get 2? Addition. Fascinating. Let's do one more just for funsies. What does it mean to have x to the 4? Tab needs handles first.
The x to the power of 1, so the x times x times x. Well, fancy x. That's x.
And now I'm multiplying that by x to the 5, which is going to give me... So I've just got x times 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 x. Benita. Yeah, because I got 9 of them sitting there. How do I use 4 and 5 to get 9? You add, plus, I heard someone say, add them, and then we got addition, and now we've got plussing. It's all the same thing. So what is the product rule? When you multiply the same base, what can you do? Add the exponents. So before we do this last one, let's shift down to the rule here. When multiplying, the same base. Add the exponents. So let's try this bottom one here. Well, how is the bottom one different than the ones that came before it? Have Nate Sandals first. Nope. You're looking at the wrong thing. I want this guy right here. How is this guy different than what came before it? There's two different types of variables. Okay. Before we do this one, I have a question for you. What's this? Benino. What is it? What's 2 times 3 times 4? How'd you do it? Tell me exactly how you did it. 2 times 3 is?
6.
Times 4 is?
24.
Did anyone do it differently in your head? Or did you all do 2 times 3 is 6 times 6 is 4 times 4 is 24? Did anyone think about it differently than that? Really? Oh, the other class had a whole bunch of different ways to think about it. All of you thought about it the exact same way. What if I went it backwards? What's 4 times 3?
12.
Times 2 is?
24.
What if I did 2 times 4? Times 3 is?
24.
It all works. You can take, when all you're doing is multiplying a chain of things, you can take that chain of things and multiply it together in whatever order you want. So what I'm going to do is I'm going to change this question. Instead of having x squared times y cubed times y to the 1 times x to the 5, I'm going to rearrange the order on that, and it's going to be the same thing. Because 2 times 3 times 4 is the same as 2 times 4 times 3 is the same as 3 times 4 times 2. It's all the same. Either way, you get 24. So I can rearrange this. I could write this as x squared times x to the 5 times y cubed times y to the 1. Yes.
Can you also write it as x to like n7 times 5?
Which I can now, well, I'm going to expand it here first. You're suggesting it should be x to the 7, y to the 4?
Yeah.
Let's see if you're right by doing all of the extra gross bonus work that I don't want to see you do after this. So x squared is going to be x times x. X to the 5 is going to be 1, 2, 3, 4, 5 of those. And then I've got y times y times y times y. Y cubed gives me 3. The extra y gives me a y. And now what have I got here? 1, 2, 3, 4, 5, 6, 7. Gives me x to the 7. 1, 2, 3, 4 gives me 4 of those. I can't do x times y because I don't know what x times y is. I don't know the numbers. It's not like I can just say, oh yes, x times y is 24. It might not be. It could be 2. I don't know. Right? Because we don't know what the values for x and y are, they have to stay separate. X and y. Guntis, eyes on the screen. Not on Yuvraj. I know he has like this charismatic personality that you're just drawn to. Ignore Yuvraj. Eyes on the screen. And we get x to the 7, y to the 4. And it stays this way because x and y are different bases. Cool. That's product rule. Now, quotient rule. What's a quotient? Mishwa.
X to the 7 times 5 or 4, just like x7 minus 4.
You just said the same thing 2 different ways. When there is no symbol between 2 mathematical objects, what is assumed to be the operation? Multiplication. So you just said the same thing 2 different ways. You cool with that? Okay. Quotient. What's a quotient? I mean, the questions should give it away. The quotient is the result you get when dividing. Pevney, is that what you're going to say?
Yeah.
Thank you for trying to put your hand up. I appreciate that. I did kind of leave it open-ended for you guys to just shout it out, though, the way I asked it. So a quotient is the result you get when dividing. So the second rule only works when? Excuse me? This second rule only works when?
Dividing.
Dividing. That's why it's called the quotient rule. No, you're good. Don't worry about it. So, I got 2 to the 4 divided by 2 to the 1. It works, but I don't like to write things that way. So what I'm going to do is I'm going to take this division statement and I'm going to turn it into its equivalent fractional division representation. I'm just going to write it as a fraction is what I mean. I'm using more words when few words will do. 2 to the 4 divided by 2 to the 1 is the same as 2 to the 4 over 2 to the 1. These are equivalent statements. And now I'm going to expand this thing. The numerator is going to become 2 times 2 times 2 times 2 over 2. Now, if you recall, chapter 1, when we were multiplying and dividing things as they related to fractions, we were allowed to move stuff around. That was the whole idea behind cross-simplifying, right? I'm just going to jump to the whiteboard here for a second. When we had something like this, if I had 2 over 3 times 6 over, 16. I mean, 3 times 16 is obviously 48, but that doesn't necessarily jump to everyone's head. So we had rules that we established to allow us to make our life a little bit easier. We said, okay, well, I can't simplify here. I could simplify here. I can divide both of these by what? 2. Divided by 2, divided by 2. That would give me 2 over 3 times 3 over 8. And there's another simplification. Now, each of these are simple, but I can cross-simplify. Why does cross-simplifying work? Well, cross-simplifying works because multiplication, you just multiply across the top, multiply across the bottom. 2 times 3 over 3 times 8, but I can multiply in whatever order I want, right? So this is the same as 3 times 2 over 8 times 3, which is the same as 2 times 3 over 8 times 3. Like, you can write it in whatever order you want. You cool with this? Either way, 2 times 3 and 3 times 2, it's the same. But if I find this, and I can line up the things that I can simplify, I can make this 2 over 8 times 3 over 3. This is going to be divisible by 2 and divisible by 2, which is going to give me 1/4, and 3 over 3 is 1, and anything times 1 is itself. This is the long, gross, ugly way to justify what we called cross-simplification, where we went back here and said, oh yeah, I can just do this, and I can do this. This long, ugly bit is why that works. This is the same thing. This says if I have 2 times 2 times 2 times 2 in the numerator, all divided by 2, I can take one of those things that I'm multiplying by in the numerator and do the division with the thing in the denominator first. So, what's 2 divided by 2? 1. So this is going to become 2 times 2 times 2 times 1. Does multiplying by 1 change anything? No, so get rid of it. There's a dirty word in math that we use, starts with a C. Cancel. We got the cancel culture going on in math class. But why canceling works, hello Lachlan, why canceling works is it's just division. Divide something by itself, the result is 1, and multiplying by 1 doesn't change anything. So 2 times 2 times 2 is going to become 2 cubed, not 8. So, but look at what we've got here. We started with, a couple minutes ago now, because I've been talking for a while, 2 to the power of 4 divided by 2 to the power of 1. And doing all of this kind of grossish work. Basic it off your phone. Unless you're translating me, then by all means that's fine. And we ended with 2 cubed. How can we go from 4 and 1 to 3? It's the same as the result I would have gotten if I had just taken these exponents and subtracted them. Because 4 minus 1 is 3. Interesting. So do you want to take a guess at what the second one should be? Manraj. Let's see if we can prove that. So let's expand this. First I'm going to write it as a fraction. 7 to the 5 over 7 to the 3. And I'm going to expand it 7 times 7 times 7 times 7 times 7 over 7 times 7 times 7. And now I'm going to do a bunch of division. Divide, divide, divide. So this is going to become 7 times 7 times 1 times 1 times 1. Multiplying by 1 doesn't change anything. So I have 7 times 7, which Manraj predicted would be 7 squared. So what's the rule when dividing, Manraj? When dividing, the same base. Subtract the exponents. And it's always first minus second or top minus bottom. So what should this one be? Very good. Because if I blow this up, I'm going to have 1, 2, 3, 4, 5, 6 over 1, 2. Divide, give me 1. Divide, give me 1. Got 4 x's left. There we go. Yes. Fascinating. Let's change the last question to give us that scenario. Instead of 9 over 4, let's change the 9 to a 4 and the 4 to a 9. I've got y to the 4 over y to the 9. So, if the rule is the same, what should my result be? Mishra. Y to the negative 5. Let's blow this up and take a look. And this is actually a really good one to do. If you've worked ahead, flip back here. I want you to change the question, make sure you're doing what I'm doing. So let's expand on this and see what's going on here. I've got y times y times y times y over, and I'm putting 9 of them in the bottom. Who thought this was a good idea? 4, 5, 6, 7, 8, 9. Boom. Okay. So what happens? Y divided by y? 1. Y divided by y? 1. It's not y. Y divided by y? 1. Y divided by y? 1. So, and I don't want to just say cancel. I want to recognize what it is. It's 1. So now what do I have left here in the numerator? No, who said nothing? How can we have nothing when Benita said that there's a bunch of 1s? Y divided by y is 1. Y divided by y is 1. Y divided by y is 1. And y divided by y is 1. 1 times 1 times 1 times 1 is? 1. When there's nothing else left, you have to put the 1 there. And now I've got 1, 2, 3, 4, 5 of these in the denominator. So that's going to give me y to the 5 left over in the denominator, which, Mishwa, just so happens to equal y to the negative 5. The result is the same, which is the secret 7th exponent law that's not part of grade 9 that I was going to show you anyway tomorrow. But this is the result. If you just do the subtraction, it's y to the negative 5 in the numerator. If you actually blow it up and do the work, the canceling, you're going to get 1 over y to the positive 5 in the denominator. This fraction is the same as having a negative exponent here in the numerator. The secret 7th exponent law that for some reason the province doesn't think you're ready to see. Yes?
For the y, right? Y divided by y, I thought it was y. I think it's what?
Anything divided by itself, anything, doesn't matter what it is. Smiley face divided by smiley face. Squirrel divided by squirrel. Mishwa divided by Mishwa. How many groups of Mishwa are in Mishwa? One. There is one, because you have to think about what this is asking. Division is, a way to think about division is, how many groups of the thing are in the thing? One. How many of you are there in you? One. It'd be weird if there was more than one of you. In you. Anything divided by itself is one, numerically or otherwise. So there is a way I like to write both of these rules. We've got our product rule and our quotient rule. I want you to go back to the product rule and I want you to write this out. When you have the same base, so I've got x times x, when you're multiplying the same base and the exponents are whatever they are. So in this case, I write it x to the power of m times x to the power of n. I don't know what m and n are, but I do know that when the bases are the same and I'm multiplying, I'm going to take those exponents, I'm going to add them together. We're taking all of the numbers out of math. You are not the first person to not like this. And in the second, it's the same. When I've got x divided to the m divided by x to the power of n, or I can write that as a fraction, x to the m over x to the n, it is always x to the m minus n. Whether it's first minus second or top minus bottom. You are allowed to have negative exponents, and you are allowed to have things show up in the denominator of a fraction. They are equivalent. It depends on the pathway you did your work to get there. There was some arguing in the last class. Two girls who sat across from each other did it separate ways, got these two results, and were arguing about who was right. They asked me to settle it, and I said, yes, you are both right. And they were confused because this had not come up in that block. So then I showed them. When you, and it's important, I'm going to state this, when you are doing, if you find yourself doing this canceling and there's nothing left in the numerator, you need to remember you're not just canceling away into the netherverse. Guntas and Carson, eyes on the screen. Stop talking to each other, Guntas. You're dividing and left with 1, and you still have to multiply all those 1s together. 1 times 1 is 1 times 1 is 1 times 1 is 1, and that 1 needs to remain in the numerator. Cool? Yeah. Because there's people who don't leave it in the numerator. They're like, oh yes, that's just going to be y to the 5. If I told you I was going to show up to your house with 8 pizzas, you're like, oh, Dweedup's coming with 8 pizzas. Let's invite some people over and have a party. And I showed up with an 1/8, 1 over 8 pizzas. And then I get confused. I'm like, why'd you invite all these people over? I only brought 2 slices for me. I brought 1/8 of a pizza like I said I was going to. And you're like, no. 8. Those are fundamentally different things. 1 over y to the 5 and y to the 5 are different things. If something is left in the denominator, it better be in the denominator, and then the numerator needs to be a 1. Those are fundamentally different values. Okay. Questions about the laws? Then have you seen these before? Are they back there in the recesses of your mind? You saw this in Columbia? Okay. Because I know some middle schools here did this and some did not. Last class, about half of my students were like, yeah, I've done this before. And the other half were like, I have no idea what's going on. Is this new for you? Is this new for you? Were you both at Abbey Middle? Where were you? You were at Hal? You were at Middle. Was anyone also at Abbey Middle did not do this? You did not at Abbey Middle? Who'd you have? Judge? Who'd you have?
I had Miss Perry on, honestly, but like.
You had Perry, but she had Judge? Interesting. This is part of the grade 8 curriculum. Okay, flip the page. There's 22 questions. Your homework is all of them. They will be quick. You'll start quick. Mila. Okay. Play with these. May the force be with you. If you'd like to move over to work with Mr. Minocha, if Mr. Minocha, you would like any of them to work with you, that's you can make that call. Carson, if you want to use the whiteboard behind, you got a box.
Is it? Okay, so I'm gonna go to the washroom, I'm gonna come back. I'll go to the far one, save more time. I'm gonna see how much you get done. And if you get one wrong, then you're coming back here. Yeah, it's a fair deal.
Okay, so Mitchell's got a good question. What kind of work do I want to see on these things? Okay, for question number 1, I do not want you to spend a lot of time expanding things. If you need to help yourself see things for the first couple by expanding, that's okay. But if all you do for me is this, that is a sufficient amount of work for me to understand that you know the law. On a multi-step question, if you have to do a couple different things, do not throw in my classroom, please. If you got to show me multiple steps, that's fine. But if you want to do it in one step, as long as I follow what you're doing and you don't screw up combining steps, you're good. For example, a question like number 9. If you were like, yes, I'm going to add these two, and then you're like, well, when there's no exponent, it is actually a 1, and then I'm going to subtract this, that's enough. Or if you were like, I'm just going to do 3 to the power of 2 plus 4 minus 1 equals. Either way, either one of these is an acceptable way to show me the work that you've done. But the questions are going to get more gross, and so you're going to have to show me a little bit more down here. But I do not. The whole point of these exponent laws is for you to not be expanding everything, because that will suck. It'll work, but it'll take you 2, 3, 4 times as long as it needs to. I want you to get the hang of the exponent laws. Okay. On your mark, it's a giver. Will you get work done out there?
Yeah.